Doot doot. Did I do it right? Lion. I'm gonna assume I did it right. Da, da, da. Yeah, so first thing I want to do today is just, I started redoing a bit of the build script. I moved one of these like meta programs out of C and I ported it over to Lua, which just makes my life a little bit easier, so it's a little bit shorter. The other thing I wanted to do is probably add a help screen to the compiler stuff. Are you coming at Twitch? Or, I mean, I experiment maybe? I don't know. We'll see. The other thing I wanted to do is I want to get back to doing linker stuff soon enough, but first is going to be just getting everything running again after having reverted a bunch of changes that I like played around with. Yeah, that's about it. So, how do I leave off on? Where's that come from? Make sure I didn't have my auto indenter on. Okay, the C flags is on, or the C flags says that it's including the thing, but if it were, then why is it not showing up? Or at least, why does it not know what this is? Prelude. I see. Yeah, I forgot to pass a -C into it. Yeah, basically, I just it cuts down a like basically just a compile step. I don't need to do any like host compiling, which also means so if you're using Clang, it doesn't really matter, and if you're not cross compiling, it also doesn't matter. But if you're using, let's say, GCC, or if you're using if you're doing any flavor of cross compiling which isn't on Clang, then you're going to need two separate compilers, one that targets your host and one that targets your target if you want to do meta programs in C. So I'd rather just have it be that I do them in Lua. Yeah, that's mostly planning for future improvements to the build system where I make it easy to cross-compile. Yeah, this meta program just embeds a bunch of files, specifically all the freestanding headers, into the quick library, so that you don't have to like carry them around. So as opposed to having like a folder where you hold all of your freestanding headers like student and such, they're all just embedded into the library itself. And let's see, what's next? Why is it telling me? Oh, I'm missing a... is the actual... what is it actually just embedded in? I'm seeing binary data. When I say embedded, I mean like hashtag embed kind of embedded. So this file gets compiled with the rest of the program, and from the perspective of the quick library, it is treated like a sort of virtual like folder. That way, when you type in to include std.int, it's not a physical file, because it means that there's two main issues with that. One of them is that if you're using quick as a library, it means you have to like point it at whatever that folder is. And if you're using quick as an executable, you would just have to define some location where the freestanding headers go. And so I'd rather not do that, because it means that I can keep the file, or I can keep the library and the executable as one unit. I mean, of course, there's still the issue of if you want to do the libc itself. So the freestanding headers are only the parts that are compiler defined. So this is going to be your student, all of your intrinsic headers. All of those are something I provide, and then the other half is the libc, which is provided by the operating system or whatever toolchain you've got. Yeah, it's just a bunch of them. The full list that I've got here is all of these basically. What do we got here? Like 14 different files, and they're mostly empty. Like there's a few that have a bunch of stuff in them. This one defines the types. This one, let's see. This one defines like all the vararg stuff, and this one actually has some stuff in it. And then there's a few that are like really empty, like EMM because I haven't filled them in mostly. And then this one, x86 intrin, doesn't do much at this moment. Yeah. Yeah, there's basically just a virtual file system in there. Now, what is the thing yelling at me about here? Flavor. What is this main use to include actual virtual files? Its main use is just so that I don't have to lug around the specific freestanding headers. Yeah, they just get embedded into the binary itself for the executable or library form. You can, in theory, embed more virtual file systems, because the way that the Quick does the whole file system thing as a library lets you just override the default file system. But the default one comes with this fake folder. It's called like $Quick or something, and that fake folder has all of the freestanding headers for arg or whatever else. Is the VSFS like virtual address? I guess so. There's just like I mean, it is a virtual address, but it like that sounds more complicated than it is. It is basically just like there's an array somewhere and it's got a name associated with it. And so like each one of these is one of the files. It'll look through this list for the matching file name and it'll just use this data as the file. It's less of like, if it fails to do this, it'll go to disk. It's technically more that this is like a folder. There's a folder that has all these names in it. I can pull up that code. Or is it driverfs, I think? No, it's actually quickfs. No, it's not quickfs. It's something fs. Oh, there you go. Yeah. C preprocessor file system. And then in here we've got like, oh, if you're inside the $quick folder, then we do the, then we handle the $quick files. And then the normal path of like going to disk. Yeah, and in theory you could just you could override this and then add more and more layers of your own virtual files. That might make sense if you're doing some sort of editor that has like a live preview or live editor for Quick. In which case you might not want to, you might want to make one of those files like a fake, like RAM file, basically. Let's see. Well, so now it launched, or like now it ran, kind of, but it didn't really compile everything. Like I haven't linked everything yet, and we go check the build.ninja. We've got a very much specific engines I worked on too, usually because they compress a bunch of files into binary blobs. Yeah, I played around with compressing files at some point. There was like a short period of time where Quick could treat zip files as like normal, as effectively normal files, so you could read into a zip file and so on and so forth. Like it could do it multiple layers in if you really wanted to, but I kind of dropped it because it was mostly not worth it. I'm not, like, most of the cost is not I/O, but I've considered bringing it back, not for I/O reasons, but for the sake of keeping like effectively like tarchives of your libc or something like that. So it's less about the compression and more about the convenience of being able to like take all your stuff and putting it all together. These interfaces will be used in post. Gotcha. Yeah. I don't know if the compression would pay off, but just being able to throw everything together might be worth it. Yeah, but that's something I'd have to come back to. So I've got the meta program here. Let's see if we can... Let's add a line between these two. So we build our meta program. We've actually got a few meta programs. The other meta program that needs to run is the one that deals with compiling the headers for TB. So we have this big table that holds all of the different flags and associates each of the nodes with whatever their like extra data is. Nodes can inherit other nodes' properties, you know, boring table generation stuff, and then all that's then later like followed by a bunch of machine nodes that define not only the details of how the architecture works, so like what feature sets we support, and then what register classes are in the backends, and then a few different like data types. There's also all of these patterns. These get auto-generated into a bunch of C code that just does the pattern matching and replaces the nodes respectively. They use a bunch of like C expressions. So all of this stuff, all the stuff in quotes is all C expressions. You could even have patterns where you match against it using the pattern matcher, but then resolve the replacement rule with C code. So like that's what I do here. So if it sees an if, it'll replace it. Is that one of the programs? Like one of the meta programs? Yep. That one's already written in C, or in Lua, I mean. Yeah, I believe it's this one. Yeah. And then actually, it's really two files. It's this one and then this arch icel file. The arch icel thing has all of the stuff to do with building up the pattern matcher because it's kind of huge. So you mainly write the specs. What do you mean by the, oh, like the feature set stuff? Yeah. I don't really do any sort of like data extraction from any sort of like site for that kind of stuff. One thing I have considered doing extraction for is like pipeline information. Like I could take the XML data from UOps and transform that into pipeline data that I can use for my own scheduling jobs, but I've not gotten around to that. And it's really not that big of a deal yet because scheduling is kind of the least of my concerns for the most part. At least when it comes to those kinds of cases where we're trying to figure out like latencies, just because on a modern x86 processor, you're working with an out of order chip, and it really doesn't matter if you put the low latency things or the high latency things in front of each other. They're both just going to get queued up, and then they'll both sort themselves out in the background effectively. It matters more if you're on like in order chips, but I have not gotten around to testing on many of those. Let's see. Hex embed. Yeah. So let me pull up the other file. Like the previous version of this build script. That's what I want to check. Okay, so it did build if I do that, which is nice. I want to know if building that does the flags correctly. So what I'll do is I'll just make an error here and see if that explodes. That did not explode. Huh. Okay. So over here we have our TB stuff, but it doesn't seem to be compiling the flags. Necessary? Oh, I see the issue. Accumulate C flags. Do meta programs have a specific structure / set of functions common between them? Not really. Like, they kind of do, but I just don't have enough meta programs for it to, like, justify its own existence here. At least within Quick. I do use this stuff, like, elsewhere. But in terms of the prelude, I've got this, like, ordered set over here, and then I've got this partitions. These are the two main data structures that I, like, end up reusing all the time. Ordered set just does, like, key value pairs, or it does... Well, really it just does keys, like sets of keys, but you can iterate it in order. And the order is just whatever, like, insertion order. You can associate a value with the, like, keys, so that's all fine, just because nothing was really stopping me from doing so. And then partition is kind of similar. Instead of associating a single value with them, you can associate a key with multiple values. So, for instance, if you wanted to say that... I'll give an example from my instruction selection stuff, because I use it all the time in here. I might have... Oh, actually, there's another place where I use the prelude, which is the partitions in the Lexer. So I'll actually use this Lexer as an example. What I might do is say, hey, all of these things are matching against the same input. So we could have like our NFA, and we're trying to build a DFA from an NFA. We notice that a bunch of things all match on the same input, a bunch of different paths. Let's say everyone matches on A. So we would add them all to the like A's list, and then I can iterate that in order. And the reason why I care about that is because Lua tables by themselves can't be iterated in, like, they don't have a consistent order. And for build, like, for deterministic builds, I do actually, like, want that to work out. Because if I don't do that, it'll, like, drastically change the shape of my, like, DSL outputs. Is written in Lua, so just a table. Yeah, it's all tables. It's tables all the way down. They don't really require anything crazy. And especially, it's not like a performance thing. None of these things take that long to do. Yeah, but let's see if that fixed our issue. Yes. So now we have our, like, defines. So up here, I might redo how I do this, but essentially for all the different modules inside of TB and Quick, I have these lists of sources, which are just like the actual source files, and then deps tells me what modules include other modules. That wasn't a good choice. And then there's also C flags that get appended between each one. There's like the, you know, work in progress Go front end stuff. There is the C front end, C preprocessor, and then the backend linker, and then the driver. The driver is the, like, sort of CLI interface for Quick. Because you can use it as you can use Quick and TB both as libraries, either separately or together. And that's true for a bunch of other components. So for instance, the linker needs the C preprocessor because a Linux linker, like an ELF linker, needs to be able to use the C preprocessor for parsing the linker scripts. So there's sometimes when you might want to, like, mix and match components, and I write out the nightmare of a DAG in this table. There's a world where I would just have them be like a nice tree shape where I have like submodules, but it kind of just didn't play out nicely. It meant that I'd have to duplicate things that I might want to share, like preludes. So I moved away from that. Alright. So now it's just time to run the meta program. So what I used to have is not too complicated, so I might just copy it over. Yeah, there's a bunch of fun things you can do with it as a library. So, like, if you want to do sort of integration with an editor, you might want to just use Quick, the library, or maybe you want to use Quick, the C preprocessor by itself. So you can choose what you want to compile. I think it's useful to do C as a scripting language, but I think C is kind of miserable. So I wouldn't want to really do much with it like that. I don't like how I do this stuff, actually. Where I, like in the old setup, I would, I'd have to put in as explicit dependencies which DSL files were being included here. But it does technically just get the C preprocessor run over it. So I could spit out the dependencies using that and treat it like any other C source file. But I won't do that just yet. Let's see. Arches. How does that work beforehand? Yeah, for now, I will actually just placeholder that with x86. Or is it x64? I don't remember which one. Yeah, so the DSL generates these two files, the private and public, and they're both empty because this thing broke. So let's go check on that. Is it x86? No such file directory. I don't actually remember how this went, so I'm just going to have to check on the file over here. I'm using Live++ recently, and the power of just being able to run Knuckles is quite fun. Yeah, I don't disagree. I just find C, like, miserable. And it was like it was not a thing that I started with, it just became that way as I kept writing more and more C compiler stuff. It became less and less of a simple language. Oh, I see what I have to do. Okay. So what I have to do is tb, what is this? Has x64, I think? One of these. Yeah. Which I will actually move up. Because it's also a flag that everything else in the compiler needs to know about, so... Alright. I should put music on this, actually, but, I didn't have the time to go pick out the most banger royalty-free jams. Mostly because I don't listen to it, so I wouldn't know. Yeah, if you've got recommendations, feel free. I do. So yeah, now that the flags are set correctly, I'm gonna get this big file for the private stuff, and then for the public stuff, I get this big file. And this contains all of the different nodes for the entire project. So if you compile with x64 on, you'll get all of the x64 machine nodes, which is this list right here. If you compile with ARM, you'll get those as well. You can actually compile with both at the same time, and so on and so forth. Although the ARM stuff is not ready for use like that. Yeah, and this is all stuff that is exposed in the public interface. I don't know why the Pragma once is there. That's really nasty, actually. Ooh. Nothing does actually stop you from putting Pragma once not at the top of the file. It's just an experiment. So I've now got a bunch of object files. That should be useful. Let's go see. So I've got all of these object files, and the D files are the dependencies. Those are spit out by the preprocessor. That way it knows when I change a source file, what files get affected. Now, step 2 is just compiling. Actually, step 2 is first deleting this stuff and then recompiling it and seeing if it recompiles everything. Okay, cool. And now I'm going to get rid of this list. And the other thing I need to get rid of is that there's a print in here, I believe. Is it this one? No, it's not that one. It's whatever prints this thing out. It looks like the list printing, or the lines, I mean. Yeah, I happen to have YouTube Premium, so I don't really deal with YouTube ads. And then on the rest of the internet, I go back and forth between Firefox and Chrome. It really depends. Oh, here it is. There we go. Now it's not printing anymore. So, those are the two meta programs now. Meta program, DSL's node stuff generator, Yeah, speaking of really, like, terrible looking sites on, with ads, every fandom site, if you've ever used a fandom site without, like, an ad blocker, it's just, like, a miserable experience. I think if can I open one? Let's search up, like, I don't know, Bluey fandom. Yeah, so we got ad over here, which I don't know why it's like scaled this way. And we got the same ad over here. And then, let's see, I'm sure they're going to start popping up. Okay, this page is too weak. Let's go look for more. Okay. Bluey, give me content. Okay, here we go. Oh yeah, the lag. More ads. There's a little video playing too. I hate how I can see it like refreshing the DOM, because every so often it just like stutters. And it's just filling in more and more ads all over the place. Because that's what I want. This is real estate, by the way. This is like my screen real estate eaten up by advertisements. I wanted to do I wanted to switch over to YouTube, and then I realized apparently you have to like request it a day in advance. So I did that like an hour ago, and then after that I will do it on YouTube, because I like the ability to do like all the DVR settings, or the DVR stuff where you can rewind the video. It's kind of nice. All right, linker time. Yeah, you have to request to be able to stream on YouTube. The first time you ever do it, you apparently have to wait a day. Or it said up to a day. I don't know if it happens quicker for some people or not. Let's see. Go live. Only blah blah blah. Yeah, you request stream access today, and you will not be getting it today. Yeah, it's only the first time. After that, it's instant. Yeah, if I choose to stream tomorrow, we'll see. Normal C source. So I think those are actually no. There's 3 meta programs in this thing. The third meta program is for the preprocessor. I've got one for every module, every cool module. Oops. The third one is the Lexer. You need a dog in the background? Why? I'm just copy pasting from the old so you can shock it. Oh hell yeah. That's what I'm here for. Did I generate the thing? Lexer.c. DFA. Well, because I didn't realize that was the reference you were making. Yeah, if I had known that we were gonna be, you know, zapping, I would have been tapped in. I would have been ready. So now it's linking time. Okay. Yeah, so now I've got all the meta programs, I think. And then the next part of things is just throwing everything to the linker, which is not a particularly interesting process. And then the next step is filling in the new CLI stuff. And then I can work on like actual my own linker, which I might do a bit tonight. We'll see. Yeah, there's a few details in the current like PE linker that I just really don't like. There's like little subtle things that are x86 focused in here, and they really shouldn't be. It's also huge. Like this is like 1,500 lines, and it's kind of big considering just how much of this stuff is basically just a parser, and then pumping a bunch of data around. Like it's mostly swizzling data, so I imagine that some of these things can be shrunk, and so I want to play around with seeing what can be shrunk and what can't. Yeah. Performance-wise, it doesn't, like, not work. Does a linker do anything interesting beyond being a glorified table lookup? Not really. Like, I guess it depends on what you mean. Like, it's mostly just like a swizzling a bunch of, like, it's just concatenating a bunch of object files together. So you put all these sections together, you take all the symbols, you merge the symbol table, and then once you've got that merged symbol table, then you just, you run your, like, garbage collection, your, like, mark live step, where you figure out what's alive, and then you, like, stuff it all away, like, you throw away whatever's not. For Windows linkers, there's a little bit of complexity that's added because PDB is not a raw, like concat job. It's not just appending the things next to each other, it's, you are, like, sort of building up this database. It's mostly, like, append-only database, but it's a database. What does LTO do? LTO is just running a compiler. I would barely consider that like a linker step. It's really just running the compiler on all of the files. Also, due to the nature of how TB works, it's not really like how things are built to work. Two reasons. One of them is because LTO is a compiler-specific thing. So if you want to do LTO for a Clang compiler, you're going to need to be able to compile LLVM bitcode. And then if you want to do it for TB, you would presumably need some sort of like TB bitcode that you would have to compile. And I don't really like that model. I would rather people just make this gigantic translation unit that has all of their stuff and then throw that all together to make the program. And that's currently how Quick works. So if you throw Quick like 4 files, it can just compile all 4 of them into one unit. And it acts as if it's being linked together, but they're really not. Like, it acts like they're separate object files. And when I say it acts like that, I mean, like, if you do an extern in one of them and you, like, import it on the other side, like, that all works out the same way. But they can be compiled in parallel, and they can be compiled all within the same, like, you know, process. Linker. Just gotta write good programs. I think LTO is like the wrong solution, but the other wrong solution would be to not have support for such a concept, or like for some equivalent. Because I do want programs to be able to like do whole program optimizations. I think it's kind of a disservice if like all of the dynamic languages end up getting away with it and the static ones can't, because then you just let them win. Like, if Java can do better, like, static tier optimizations around a whole program than you can, then, like, you're probably doing something wrong. It should be the case that Java beats you on the dynamic stuff. Does it do precompiled headers? No, I don't do precompiled headers. I don't have a reason to yet. Yeah, like, it just hasn't come up. If it's Windows. Also, if it's a library. Let's see. Okay, if linkers are anything beyond concats, why are they slow? Because you have to parse a lot of data. And depending on the linker, you also don't... so you're basically doing... You're a lot of it is literally just copying stuff, so it's like an I/O thing. The other half of things is parsing annoying formats. If you're parsing PDBs, then that's like a database, and then that becomes annoying, and you do actually have to like swizzle the data a lot more. If you're dealing with linker scripts, like let's say on Linux, which there's going to be a bunch of them hidden in all your stuff, then you'll run into problems there. And then the other one is the sheer scale of things. I don't know if I have it around here right now. Let's see. Hopefully one of these boots up. Nope. What about this one? Oh yeah, here we go. So one of the things you run into is that there's just like a nice big chunk of like object files. So all of these little things, these are a bunch of object files, and I'm parsing them in parallel. And then I've got like the lazy parsing, because you also don't want to expand out all of the files. What you'll do is you'll have so you'll have your, let's say you're on Windows, you'll have your .lib. Inside of there's a symbol table. If any of the symbols in there get hit, it'll tell you to load one of the object files, and then that way you don't have to load all of the object files inside of a .lib all at once, or all at all, really. And that cuts you down like a huge amount of like symbols and objects, because in practice people don't use that much. So like you have your .lib that might hold the entirety of your libc, but if you don't use any of the math functions, it just doesn't include them, and that's a good thing. It just saves you on I/O. So you have a lot of these. I think in total for this thing we've got somewhere around 257, but the entire .lib has like I think like 5,000 or something. I'm sure I wrote it down somewhere. Let's see. Yeah, depending on the linker, you also struggle to do the multi-threading. That's not something that has to be that way, it just happened to be that way. As in, linkers were just not written to be multi-threaded at the start, and then people like didn't necessarily get that good at them until like LLD. Don't worry about it, by the way. Don't let my question derail what you're working on. I will get derailed by anything. It's not... Yeah, it's not like a you thing. Yeah, I need a dog with a shock collar to just like keep me in check. Nil. What's nil for? Let's see. Currently looking how I used to do the linker script, because it's kind of nasty. I would at some point want to support MSVC, especially because MSVC is starting to support some of the newer like C features. They were like really behind, and so I just didn't like the idea of supporting them at all. The compile times were not worth it either. Like people talk about the MSVC compile times being really good, but if you do incremental compiles like I do, it like none of them really stick out because most of your compiles are pretty quick. It's not like I'm doing like a fresh compile every single time. It's also not a particularly big project, so it also really doesn't matter. Alright, LD flags, where are they? Right here. There's none of them right now. I don't keep track of how much, like, Overhead Ninja adds, or, like, how much it really saves me. But I do know that, like, a fresh compile is going to be a lot longer than what Ninja usually offers me. Yeah, I haven't, like, measured it, but I just know, like, vibes-wise, I can see that it's faster. LD flags. What are the rules? Fine. But sorry, that I have a very little number of files, or that you do? Because if you're saying I do, then, like, yeah. Oh, gotcha. I do this weird thing where I place it next to it. I don't know why I do that, but I'm a little afraid on the reason. Because I'm pretty sure the reason is so that I can support the MSCC linker style of doing things. Where you might do, like, out file name, as opposed to doing, like, -o file name. In which case, I wouldn't want the space in the way. But I don't know, because it's been a while since I've actually looked at this code. Yep, that's exactly why I do that. Now the next question is, where do I define what the linker is? Right here. I've got a nasty looking, like, linker thing here. Speaking of cooking, I should make this hot dogs you recommend. Hell yeah. I don't even know if oh, actually, I was the one who recommended the hot dogs. The Seattle dogs. I don't like this. I don't like the fact that I've got this, like, stack thing, because I remember why I did that. I was trying to run something, and I did a big graph walk that I've not converted over to a work list like I'm supposed to. And so it stack overflows. I don't know why I do it this way. It actually make more sense to just use the compiler to do the linking step. So I will just do that, actually. That is how that command goes, right? Fuse LD. Yeah. Do that. Press that. Have you streamed before? I have streamed like a few times before, but like the last time I streamed was 9 months ago. Yeah, this goes here. Windows. Yeah, I can just save myself time if I don't use if I don't call the linker myself, which I really don't have to, so might as well. In which case, these are the settings. I need to redo the CLI, because there's really not much I want to change from the CLI. The only thing I really want to change is the fact that I don't have a help screen. Because I've run into people telling me about, like, oh, the CLI changes something like that. It's like, it would be so much easier if I just kept the help screen on the CLI. That way, when it does change, people can just see, like, any of that. I'll leave that like that for now. For a nil value. Yeah. Entry point must be defined. I don't have an entry point. Oh, okay. But right now I'm just manually calling these walk functions. When I call it, it just it compiles and imports the rest of the dependencies. So the plan is to hook the new CLI interface to it, as I did with the old one. M. Do what index M? Why not? Oh. See ya. Let's see. Yeah, okay, there you go. So now I've got all my files. And if hashtag embed was a more like, you know, reliably defined thing or like reliably implemented thing, I would just use that. And maybe one day I will support it. Or like here. Because it would save me from, it wouldn't save me from running the meta program, but it would at least maybe save me on something. I'm not entirely sure. I imagine it's still gonna take a while to compile, because doesn't hashtag embed lower it to like still numbers and commas? I doubt it would cost that much though, like in terms of compile time, just because I don't change it often. Alright, there's a quick now. Let's go test the quick. Cool. Oh, it's doing the thing again. So right now, it just keeps recompiling all these units, which I don't know why it's doing that. Let's go check build.ninja. Nope, that doesn't fix it. I just realized this thing is changing order. Oh, that might be why. One sec. It's because these are tables and they don't have reliable orders. So, let me. Nope, it still doesn't. Okay. Lecture generation. So lecture.lua says that it only really makes 2 files. And from everything I see, it only really makes 1 file. Which, like... Oh. Alright. Oh, okay. Yeah, so if I misspecify it to have 1 extra file, I guess it just keeps trying to recompile it all. Yeah, right now it's a command line thing. It should have all of the features themselves. Actually, no, not yet. Because it is putting the executable in the wrong place, and that's a problem. There we go. Did I break something when I was reverting things? What did I break? Oh, no, wait, I know what I broke. The new Lexer generator doesn't support classifying identifiers. So it can't tell, it thinks that all the keywords are normal identifiers. I was gonna change that up, but I've not fixed that yet. The way that I'd done that before is that I had a perfect hash table. I'm probably gonna do the same thing. Yeah. Could actually try to fix that now. So this is effectively the auto-generated Lexer stuff. Because originally I did have a DFA, but I had to manually encode it, and I also had to manually pick equivalence classes. But now I can just write them in what is effectively regex. Where is it? I can write them in effectively regex, and they come out in the shape of these two tables and an interpreter for these, which is the part over here. Yeah. The whole process has me like sort of, because to generate, so these are like Lexer equivalence classes or character classes, some people might call them. The way that they work is that two characters don't ever there's never a case where two characters match against different kinds of things, so they can always be treated as if they were the same character, and then you just merge them. I've only ever seen people do these manually, although doing them like automatically is like entirely like a strict like practice. You can just do the math for them, which for me mostly boiled down to doing DFA minimization with Hopcroft's algorithm. From there, that gives me a bunch of partitions of equivalent states. So, these two states, any two transitions that these two states make will all, like, they'll all be the same. So you could have, like, you could have a case where you have, like, 0 matches with, matches against, or let's say state A matches with 0 to go to B, and then B matches with any to go to C. And we've got another state that's like A goes to D, which matches any to go to C. There's nothing saying that, like, B and C are the same state. So we have 3 partitions here, or B and D. Because we can say that for any, like, any transition that B makes, D would make the same transition, so they're indistinguishable from each other. In which case, it would be like this. But the nice thing about this setup is that this gives us our state level equivalence. And what we're looking for is effectively input level equivalence. So we want to see that any case that takes in 0 also takes in 1. And then if so, then they both can be treated as the same class. And so we just build out, like, we sort of like, in my head it kind of looks like a transposition, but we effectively, so from these minimized partitions, we check if there's, we can make a key of every state that accepts 0, let's say. So 0 goes into B, well, really every partition that it goes into, so B, D, and then from there, C also can take it in, and so on and so forth. And the same thing is true over here. If the set of states that B and D can both be matched against are the exact same set of state, or like, if the set of partitions, the state partitions, is the same between 0 and 1, then they're both like input congruent in a sense. And then from there we can say that they both go into their own equivalence class. But this is now not state congruence, this is input congruence. And then that code is not particularly complicated, so I'll probably just walk through it. It's somewhere around here. So it starts over here. This part just flips the, we need to know which, we need to put these things into partitions. So this whole thing, so this loop over here is all the DFA minimization part. We do Hopcroft's algorithm, we just keep splitting them and splitting them until we eventually end up with sets that are, every element in the set matches against the same sets of, like they all take the same transitions to the same, or to congruent successors. And then once we do that, we build out this, like what I call the dual partition, which is effectively the input congruence thing that I mentioned over here. And then once we do that, then we just take these, and then we just say like, oh, okay, so if they match on this side, then these are actually the same, 0 and 1 are equal, and in which case they both go into their own thing. The thing is, you could have cases where they sometimes match and sometimes don't. What you're looking for is exact matches, and that's what I meant by like it's like a strict math. Because if you get inexact matches, then that's a case for really playing around with like fancier forms of inputs in your DFA. There's like some papers on like deep packet inspection that talk about like trying to play around with like and I did a little bit of this stuff, not for the deep packet inspection stuff, but for compiler-y things, where you might say match against a state of some already defined value. In my case, that might have been like a token, where I say match against the first character in the token. So if I wanted to combine the pattern that handles plus plus and plus equal, and let's say times, and like, I'll just use this. There we go. If I wanted to unify these two patterns, the problem I run into is that like I can't say that these two are congruent, because the second, once the DFA like discriminates, they can never merge back in. So it's like this weird like zipper thing where like you only unzip at like one point and then it goes out. And so once they fork, you can't join back in. But if you can have these sorts of weirder transitions where you can say match against the first character, then we could say like C equals and then CC, where C is the first character. And then we could like write it out sort of like this actually. These both go to the same, like these both take the same state, so let's call that like D or something. And then D is like the same thing over here with like, that's like a terrible way to write that actually. From like, let's say we match plus and or, and we go to D. So let's do like that, A to D, and then from D we can either match against C, and C is our sort of like pseudo input, like our pseudo letter, and then that matches against E. So now we've got both plus, what's it called, plus plus, and then like XOR, whatever, like caret. And the same thing is true over here with like the equal sign. That can go against F. And so now we can join even weirder patterns. But I played around with that for a little bit, and then I decided not to for this lecture. If I'm trying to shrink the lecture a lot more, I could do stuff like this, and it wouldn't be the worst. I could show what the I believe I can show what the remaining equivalence classes are. So these are the ones I got, like once I'm done with the process. And over here should be the partitions. These are the minimization like partitions. So for every one of these, these are all the different inputs that these things can take in. So both state 30 and state 27 both can match against any of these and like move forward. And then so the question is, does anything ever appear? Do any inputs all appear in the same sets? And in which case, so we can see 0 is over here. Does 0 always appear in the same set as 1? And so 0 is over here. 0, 0, no, 0, 0. So that means that 0 needs to be in its own partition, and so it's split from the rest of the numbers. But does 1 appear in the same sets as 2? The answer is also no. But does 2 appear in the same set as 3, for instance? And then now we've got like a case where, okay, 2 and 3 actually do both match against the same partitions. They always match in the case over here, for instance, for like this is for normal, this one's for octal. This one's for like normal decimal, and then this one's for identifiers. And so there's nothing ever distinguishing, like we never actually discriminate between 2 and 3. They're always numbers, and they're always in the same sets of numbers. But we might discriminate between 0 and 2. 0 might appear in front of a hexadecimal. It might appear as 0x, or like the 0 in front of an octal digit. And so we can't just like combine those. So we got like 20 of these, which is like not the worst. And we have like a few like off-brand cases, like over here, like 8, 9. This happens because the set of octals and the set of decimals is like missing the 8 and 9. And that's only because I really do try to parse out that kind of information in this lecture. The other thing you could do if you want to shrink the lecture is actually just cut down what the Lexer matches against. So instead of, like, I've got all the, like, not all of them, because I actually haven't finished the thing to support floats specifically. But one thing you could do to make your Lexers smaller, or your DFA smaller, if you need to do that, is you could cut down what rules it matches against and handles in post. So, for instance, I could say here that I match only against integers, and then I don't have to support any of the float stuff. The float stuff can be a sort of, like, slow path that happens if you match against an integer and then a dot. Or if you match against a dot by itself. Really, if you just match against a dot, actually, now that I think about it. Because you can do dot, like 0.5f. But yeah. I do the same thing, actually, in terms of compressing the DFA over here, where I say the quotes are, the strings are actually matched, in, like, code. There's just a sequence of code that deals with the garble of parsing, escape codes. It's not really complicated at this moment, because it just kind of checks for backslashes and then skips forward. But that's the main idea. Let's see. Yeah, getting back to productive work rather than rambling. Oh yeah, and then I build out these pattern tables. And so from these tables, it figures out the rest of how these things get minified, or like minimized. And then how do we figure out all the like equivalence classes? So like, oh, these two, let's say, I don't know. I'm sure one of these can like be matched against each other. Yeah, probably all of these just matches, like, it's a single character, so they're all congruent, and they're all like input congruent. I'm calling it input congruent, but I actually don't know if there's like a technical term for what I'm thinking of, where it's not state level congruence like hop cross partitions might give you. It's input level congruence, as in like the sort of like dual of that. Oh yeah, time to do the keywords. So for the keywords, I just need to put them into a table and then say that the table is a perfect hash table. And what I do for that is just check if it's got any collisions, and if it does, then I cry. Really, I just pick a different number and then try again. Like the seed is just going to be some value that biases them by some amount. The newest hash function is like an actual hash function. So what I would do is I would say like, here's like h, which is like the input string, and then we'd have some magic number that's picked randomly, and there's one of these surely in there that would work. I think I played around with this elsewhere, but if you multiply by a prime number, no, if you multiply by a magic number, whatever number you're going to solve for, and you modulo by a prime number, I think that there's always an answer, given some like min bound on how small the modulo can be, like how small the prime number can be. And I think it needs to just technically be, the prime number would just need to be bigger than the capacity, like the number of items you actually want to fit. And there is technically some magic number that could get you like a one-to-one mapping for a perfect hash table. But the problem is that if you just do it that way, and you pick the smallest like prime number you would like see, you might run into the problem of needing to like make a magic number that is so big that you like it's just no longer worth it. But if you just like bump that up a few like digits, like let's say I don't know, I've got 8 items or something, and I want to fit them into instead of fitting them into, I don't know, the next prime number, what's like 13, 11, I think 11. 11's, yeah. Instead of fitting into like 11 items, I might fit it into 31. And in which case, I might have an easier time finding a number that would get the hash function to modulo such that each slot gets its own each slot gets 0 collisions. Yeah. So I might toy around with that. I might also toy around with this hash function. We'll see. There's another place where I toyed around with perfect hash functions, which was a little different. The one inside of Quick for the sparse switch statements. If TB gets offered a very sparse switch statement, i.e., and by very sparse I mean not that sparse, like I think, I don't remember what exact numbers I used for it. 25%. Okay. So if you have 1,000 entries and only 250 of them are filled in, you may or may not get dropped into sparse mode, where it just uses a perfect hash table. Yeah, and it just keeps trying that until it gets something that works. Which surprisingly doesn't take that long. And it's one of those cases where it's really useful that Quick is just like faster compiling, because it means I can spend the time on other kinds of wackier optimizations that you might not want to justify if you're like really bound on compile times. Like if you're taking 60 seconds to do some compile, if I can cut that down to like 20, then maybe it's worth spending an extra second on perfect hash table construction. Like in aggregate, not like one perfect hash table just gets constructed in like 1 second. Ideally not. Like we're still talking like in terms of normal, like let's say 100, 500 element like switch statements, which is already kind of crazy. It's probably only still going to be in the realm of milliseconds. But like sort of like in aggregate, we can afford far more wacky optimizations. Let's see. Yeah, so I could do the prime number trick, but I'm actually going to start with just the taking one of these hash functions, passing it some number to bias it with, and then picking that, and then figuring out if I can find any collisions there. So now I need to port this over to Lua, which is kind of a problem, because Lua doesn't have 64-bit integers, does it? And I need portables, 64-bit integers too. No, we look for... We look for 64-bit integers in Lua, and we see if we can find something nice. I'm really looking for like 3 operations: shift right, multiply, and then XOR. 2 of those are trivial to implement: the shift right and the XOR. So really, I'm looking for multiplication, which I could emulate. I'd rather not. I also don't want it to be a Luagit thing, so I do need to make sure that I implemented the whatever is the most standard friendly Lua 64-bit integer emulation. Lua 5.3 integers. Let's see. Wait, does Lua support 64-bit integers? Okay, it definitely makes it look like there's support for 64-bit integers, but I don't know if that's true. Okay. Back to searching, because, yeah. So, integers. Okay, now I think I'm running into the next issue, which is that LuaJit disagrees with Lua on how the new integer stuff works. So that might be... Okay, so on normal Lua, so I'm using LuaJit right now, but let's try to write it and see if it explodes. capacitor 100 for now. What's the XOR symbol? I had an old setup that used a broken version of a multiplication, I think. It was doing like a 64-bit-ish multiply. Or actually, I think it was doing 32-bit-ish multiply. But the problem is that there's like, since a 32 by 32 like product is potentially 64-bit, it ran into precision issues in Lua. So I think what I need is what I did there is I tried to like just emulate what it would do, but it was kind of nasty. Let me just do the full 64. What's it called? There is a solution though, which is that it does give me, oh actually no, it doesn't, because floats are nasty. So one of the reasons why I ran into problems was because if you do, if you try to implement a sort of like low bit multiply, like if you have your low bit multiply, you lose some precision if you try to do the full 64-bit output. So like, let's say through two 32-bit values get multiplied, the full product could be 64-bit. If you truncate that into floatland, you get like, I think it's like 53 bits or something. But the problem is that those 53 bits just chop off the bottom bits. So you're just missing the bottom bits. And now your answer is subtly wrong in a way that's not, like unlike integer truncation, you're not going to just chop off the top bits, and in which case you could just make and implement a like high multiply. You're gonna get the bottom bits chopped off, and that's not nice. So now the question is, can I avoid that? And the unfortunate thing is that I think the way that I would avoid that is I would do I would split the multiply into 26 bits. So it'd be 26 times 26, and then another what's the top bits for that look like? 6 times 6? But that sounds bad. And at that point, I don't want to do it. So then the next solution would be to just do like a 16 by 16 to then emulate a full 64-bit multiply using the 16-bit one to make a 64 or like a 32-bit one, and then using a 32-bit one to make a 64-bit one, which is nasty, but you know, I think I could do that. Easily my least favorite experience with Lua though, but we'll make it work. All right, I've made multiplications before because, you know, this is a compiler. We've had to do a few flavors of these kinds of things. So, in the very beginning, what's the deal with the Lua limitation is that on LuaJIT, you don't have access to 64-bit integers. They just cut off because they only do 5.1 with extensions. So there's a bit of inconsistency, or I'd have to implement like sort of two routes. One of them supports 64-bit integers because I need them for, I'm writing a hash function in Lua, and the hash function is 64-bit. And so Lua's not really built for that kind of stuff. Lua 5.3 has integers, 64-bit ones, that would work for this, but LuaJIT does not support that. And so I'm building like these sort of emulated 64-bit multiply, but here's the problem. If you do a 64-bit multiply, if you break that down into a 32-bit multiply, like let's say I could do 32-bit multiply, 32 times 32 gives me like, you know, 32-bit output, so I only get the low half. The problem is that since we're doing them by emulating them on top of floats, when you truncate it back, you can only get back at most 53 bits out of the 64. But those 53 bits that we get truncated out when we like get back our 32 by 32 product is going to chop off the bottom bits of precision. So for instance, if we do a big enough multiply of 32 bits on LuaJIT, we might lose, let's say, the tens values, like everything like below the tens. We might lose everything below the hundreds. We are not going to lose necessarily everything above the whatever billions that we're on. Like, let's say we're on like, I don't know, not quintillion. What's a big number up there? Like trillions. Like we wouldn't lose the top bits. We'd lose the bottom bits effectively. And so because of that, I can't do a precise 32-bit multiply, a 32 by 32-bit multiply, to get like a 32-bit output. What I would need to do is, I could do a 16 by 16 multiply to then build up a precise 32-bit multiply, and then use that to build a precise 64-bit multiply. And I think that's what I'm going to go with, because I don't know what else I should do. So, to rip some code from my, like, sort of compiler, let's see. So step one is going to be the mul-high 16. So this will give, so we'll do 16 by 16 multiply to get a 32-bit product. Or, well, to get, like, the full... We want to get the full 32-bit product, because we'll need that for the rest of the stuff. Yeah, that sounds about right. Step one. So this function's not too bad. The way that it, what's it called? The way that we port it is we just cut these values. So these are built for the 64-bit variant. We're gonna need we're building a mul-high 32, which means that these get chopped in half. And then these values get chopped in half. Yeah, emulating integers with floats like has some oddities like this. Like this doesn't come up if you do addition, because addition at best adds one extra bit. And like the product of an addition, like 32 plus 32 bits, is going to give you 33 bits at most. But that's not true for multiplication. Multiplication will add the 2-bit counts. So 32 by 32 will give you a 64-bit output. And that's when we're fucked, because we passed the 53 bits that were like guaranteed. But that's okay. We got this. believe when I first ripped this from Hacker's Delight, the variant that was in there was actually to emulate 32-bit numbers, because the machine that they were describing did not have, did not support a 64-bit multiply, so you couldn't just get the... So, to clarify, this is just getting the top 32... Wait, no. Did I do this one right? This one's getting... Yeah, it should be getting the high 32 bits, but actually I can't do that just yet. I need to do the high 16 first. That sounds wrong, but I'm pretty sure. So let's do that. So I need to do high 16 first, and then we'll test this just to make sure that I'm doing this right. Because... No, I was doing it right. So this one would be, yeah. So it'd be like this. 16. Because this would give us the, high 32 bits, which is the part that we're failing to extract. Actually... No. No, this is the part we're failing to extract. I think that's right. We'll see. We'll see in a sec. I'll just like pull out a... How does a Lua bit thing work? Let's see. Okay, so well, high, let me see. Oops. Zero. No. So we can do, so these are precise 32-bit ones, but if we did a precise 64-bit one, or not the precise 64-bit one, but if we went up a few digits, what we would get is instead this, which is going to be subtly wrong. So let's grab. I hate when YouTube or like Google truncates my things, so I can't. It's a calculator. No. Give me 0. Alright, cool. 1, 2, 3, 4, 5, 6, 7 times 7, 5, 8, 4, 3, 2, 1 gives me this number, which in this case it is still in range, but that's because we're not asking for enough bits. 1 sec. So I'm not sure if C types will give me the precise so I need a precise 32 by 32 multiplication. Like, if I can multiply two 32-bit numbers and get back the exact integer output that is 32-bit, even if the full product is bigger than like 53 bits, because that's kind of the issue. I can show what that looks like. I should add a few more bits to this thing. 1, 1, 1, 1. Let me just pull out like a, I don't know, like Wolfram or something. Please just give me numbers. So this is the value that, what's it called? Let's see, plain text, copy, give me the digits. Give me all the digits. Zero at the top. Let's see. We'll try that. But so essentially, these two values are supposed to be the same multiplication, but they're definitely not. So you said that C types could solve this though. Let's try that. Legit C types. Let's see, or like FFI types or whatever the fuck. Because I thought FFI types could only do 32-bit integers still. Let's do actually, oops. There we go. Oh, I overshot it. 1 sec. So okay, so this. So what did you answer? No, I've not really responded to that. 1 sec. I'm just testing things right now. I'm gonna see if the FFI types work. So I'm pretty sure they're gonna run into the same issue that I'm thinking of. But if they don't, that would be really nice. Cause yeah. Because that would save me one of the layers of emulation. Whoops. Oh! Wait a second. That looks like it did actually work. So over here we've got like the FFI types value. So you'll notice that the bottom bits are the ones that are zeroed over here. This is the float issue I was referring to, where like if you do the full, if you emulate 32-bit multiplication with 64 or with floats, you'll lose the bottom bits as opposed to the top bits like a normal integer would. But it seems like the FFI types are keeping them, which is good because if it does that, then I can actually use it. And in which case, I only need to emulate the top half. So Now I only need to emulate doing the top 32-bit multiplication, which is this function effectively. Although I don't know if I wrote that all correctly. We'll see. Okay, so now, let's see. Now I'm sure I'm missing one last thing before I can have a full multiply, and that is okay. So if I'm understanding now, for the low bits, I would just do what's it called, low A times low B. Then for the high bits, it'd be what's it called, the partial bits that, like the bits that flow up from the low product. So I need the mul high here. So mul high, low A, low B, plus the high A times high B. I think. And in which case that would be a precise 64-bit multiply. Or, yeah. Using only 32-bit precise multiplies, which I now have access to. Okay. So. Oops, I just printed out the same number. But I've already run into problem number 1. So, over here, when I truncated the numbers, I'm losing the bottom bit again. Or like the bottom bits. Actually, if I do it this way, will it work? Because the problem is I don't think I can encode a 64-bit number into here using the setup this way. Although, actually no, there's a way to do it. You have to put like suffixes on it, don't you? So it's like, doesn't this work? I hope this works. No. Got C data. Good, I think. Oh. Okay, so now we got the bottom 32 bits. Okay, cool. Precisely, too. So with the bottom 32 bits, now it's just a matter of doing the low half of the multiply, which is just this. And that is possible to do. Yes. I think. Actually, wait. Can it do the 64-bit ones? Can, like, if I do... am I complicating my life? If I just do a 64-bit thing, do I need to emulate it at all? I sure hope not. One sec. Because if that's the case, then I'll just write a function that just, like, wraps the, like, the Lua ones and the LuaJIT ones, and then, like, I'll be happy. Can I just do that? Is this precise? That looks precise, but I don't remember what the thing looked like. Oops. No, okay. Yeah. Oh, okay. Yeah, no, I thought I could only get to 32-bit precise, but then okay, that makes way more sense. Okay. That still sucks that they have separate approaches to doing it, but at least I can work with that. Okay. Let's go back to this thing. And now what we need to do is use... actually, I can't do that. You're gonna need some coffee. Real. So now... How does normal Lua do 64-bit integer literals? Like, does it also require suffixes, or does it work without them? I assume it doesn't require suffixes, but... yeah. Okay, now question number 2 is just... 64-bit literals are tough. Yeah, I'm trying to... I would expect it not. Yeah, I might need to... I'll just write 2 separate code paths, one with the suffix and one without it, because the thing that I think would get me to, like, make it work is just doing, like, a string. Because if I do it with like a literal, then sometimes that'll be parsed as a double, and in which case, like, LuaJIT will lose to precision if it's parsed as a double, but I can't use a suffix if it's a normal Lua, so I think what I'll just do is I'll just write 2 code paths. So now, how do I check if I'm on LuaJIT? LuaJIT check, or how check, Lua check if LuaJIT. There we go. Hell yeah. Oops. First, I'm trying to see. Actually, no, it's just ULL like that. I would not know about the FFI interface. I wonder if, hopefully Simp does, because, you know, he's tapped in like that. Nice beard, by the way. Didn't realize you were chill like that. Oh. I'm sure I slept hours. Oh, 2 integer. Wait a second. Oh. Fuck. calls this function? Can I call it directly? Yeah. I'm crying. The fucking Google AI lied to me. It told me that if you use two-number, but with like a big enough number that's not representable by a double, like an integer that's not representable by a double, it'll treat it as a 64-bit integer. It was fucking lying. You also can't put like the ULL thing at the end of it to do like number literals that way. So it's not. It's a straight lie to me. I'm hurt. But at this point, I've got like what I need. So now it's just a matter of figuring out how I want to approach this part. B or B shift. Byte. It's not called XOR, is it? Oh, numbers. Okay. Now the question is if I did that right. Sure hope I did. First character would be at the bottom. First character is an A. That's 61. No. Should be like 41 or something. Or, no, actually lowercase. It's a lowercase a, so it should be like 61. No, that's great. Alright, cool. Close enough. So now the question is whether or not we can map our split table into a nice table. Nice little table. if I just pick random numbers, if I even just picked the numbers, I would eventually do it. So I think that's where I should really start, actually. Before I get to anything else. How many keywords do we have? We have 76 keywords. So we're going to pick a table. Or simply pick the real number. It's too small. I need to pick something slightly bigger. First, 20 prime numbers. Okay. I actually need just a little bit more than that, because apparently the 20th prime number is 71. Okay. 79. No, that's way too small. Okay, what's the next one? My favorite numbers. I'll pick 101. 101 seems like a cool number. So now we just multiply by a magic number. We'll call it magic. And then we modulo by a prime number. And by the law of whatever this guy was, Fredman Komlos, and other guy, you'll eventually get a number. I think that was the one. Somebody did this. The law of large hashes. There's eventually an answer, probably. He blundered. He misspoke. He thought he was gonna pull off the funniest shit, and then he fucking misspoke. Let's see. "19 ones in his favorite." So, you know, as it happens, what's it called? This hash function was entirely ripped from him. I don't know where he got it from, but he mentioned it in one of his things, and I was like, wow, that's really cool looking. I'm gonna be taking that. This one, which he got from. I mean, it looks a little different, but yeah. I happen to have stolen all the best hash functions. Actually, first step is just going to be doing this without checking. So we already see some collisions. So now what I'll do is I'll just count collisions. So first, if not table, actually, yeah, no, if table, then break is true. Not equals true. Break. Um, fun fact, the for-coder internal calling commands shit does not have, there we go. It does not have a Control-C option, so I'm actually not going to run this in there. It's really not built for what I've just tried to put it through. Actually, shouldn't just, oh, whoops. Actually, no. If collisions is equal to 0. Now I won't print out the number there. That does not look like it's getting any better, but you can see the numbers going down. It's totally like uber exponential, but it's going there. Okay, now we wait for it to go 11, and we just keep doing that until it gets there. I mean, what I could also do is just pick a bigger prime number so it takes less time to find the exact answer. Because that's really slow. That's going to take a few, like, that would take days. We're only at 10 bits. Let's pick 139. Oh, 10. Oh. See, it's making progress. Like, if you left it there for, like, in theory, it would eventually finish. There's only so many numbers. Kind of. It'll take a lot more than gallons. Now we just wait. So the bigger prime number we pick, the easier time it should have converging. If we started with like just uniform like random numbers, we should in theory converge just about the same. Although I don't know. Like, I really don't know how this stuff works. As in, I know that there is a number for it. And like that part kind of makes sense when you look at what like multiplying and then modulating by a prime would look like. But it's more like if you embedded a bit string into anything, actually. It's really just embedding a bit string. The thing is, I don't know how you fast path the bit string itself. Yeah, thinking of it like a number is actually like not good. The console takes a long time too. Oh no, I'm okay with that part. Like I'm okay. I want to be able to see the progress. So actually, let's make it only dump it every few somethings. Actually, yeah, that's what I'll do. You know what? I just won't print. I don't need to print. You're right. Already don't like it. Okay, I'm gonna put every time the best changes. Oh, that's true actually. I don't know why I didn't consider that. Yeah. Okay, I think a slightly bigger hash table. Let's see. 151. We'll pick that. Actually, let's do 149. Let's take it step by step. Ten. Okay. 9. Okay. I'm not gonna lie, doesn't look like it's doing anything. Oh, I'm also kind of being weird about this. Okay, so I shouldn't. I should bump it by like some other number, and I should also make this into a. Oh, I changed the wrong number, didn't I? Wait, no. Yeah, I did. That's why it's converting so slowly. I changed the wrong number was changed. I was supposed to change the prime over here. I changed the magic. That just chooses like the starting point. Okay, no, this should now succeed. Okay. There we go. Now it's converging significantly faster. Let's see. Can we get to, like, can we solve it? I'm way too impatient for perfect hash tables. Yeah, it's one of those things. I've done it a few times. Except beforehand, I did it with just picking a random number, and then I didn't even modulo by a prime. I just picked a power of 2. Note that if you pick a power of 2, it will not necessarily converge. So you just have to pick a magic power of 2 and hope for the... Like, it's all luck-based at that point. But if you pick a prime, then there is a non-infinite number. Oh yeah, you it's like a it is like a Fourier transform now that I think about it, but like in the worst way. It's like a Fourier transform, but we don't have like a closed form for, or maybe we do. That's the thing. I might be bullshitting. Maybe there is like just a closed form solution for like get me map all these bits to this bit string reliably without running a bajillion times. Because actually, I don't know. You'll notice that every single one of these, it just keeps getting exponentially larger and larger. It's like, oh, 4x, 4x, or something like that. I don't know exactly how much it is, but it's like, there's numbers going up. It's gonna take a while. Which also means that I'd rather print out some progress between. So, what I'll do is, I'll do this, and then progress will just be... The perfect hash function that I've used before in Quick doesn't work like this one does. Like, it does the first half like this, but then it breaks it down into a bunch of buckets that are, like, smaller, and then it does the, it's like the compressed hash displace one, or the, yeah, the hash displace compress, that's the one. And then, you basically break it down into 2 layers. The first layer is your, like, perfect hash table on top of everything, and it won't be perfect. It'll like have some entries with like 2, some entries with like 3, and some entries with 1. And then for every entry that has 2 or 3, you have to make a secondary hash function that works on that specific bucket that differentiates between those remaining entries. And because of that, it's like, then it's like more bounded in time. Because once you get down to like a small enough number of them, it's like really not that big of a deal. But you gotta get down to a small number of them. And I'm not doing that here. There's 2 reasons for that. One of them is because it just takes more code. And for 73 entries, or 76, or whatever number of entries, it's just not worth it. For the kinds of perfect hash tables that I'm trying to build in Quick, or like in TB, when it comes to like switch statement stuff, it's usually for cases where somebody has a really hilariously sparse switch statement, and they're doing a lot of entries. Like, let's say they're doing 1,000 entries. Because then it doesn't really matter if you do, like, 2 sets of, like, table lookups. Like, compared to doing a, like, a log search kind of a thingy, it's just, yeah. No, magic number is the one I want to change because prime is the capacity of the hash table, and I'm trying to make a perfect hash table that fits into a specific capacity. If I up the prime number, that's like it's not a bad. Well, like I mean, it kind of is because it makes the bigger, like it makes a bigger perfect hash table. So like I might want to up it, but in terms of the number that I'm like actually searching for, the number I'm searching for should be the magic. Yeah. The magic is whatever factor gives me the perfect mapping. Let's up it a little bit and see if that... Because it will converge faster if we just up the number. Like let's say I put it at 1009. Let's do that. You can see we've almost converged already, because it's just so much easier to find, like, a one-to-one mapping at that point. Yeah. But now our load factor is what? 76 or we've got like 7% of the space used. I'm actually surprised it's still stuck, even at that scale. So I'm gonna actually check on something. Let's make sure it's not just broken. Do... Oh, you know what? I just realized. I didn't double check this before I started, but to clarify, are the first 8 characters of every single one of my entries even unique? It's like an important question I should have actually checked before I started. Because I might just be like... I might have just screwed it up from the start if that's the case. So table... If... what's it called? Let's see what x bit to hex... Because by default, if I remember correctly, the C types don't... you can't use them as keys by default. Or like, they'll do like pointer equality stuff, and you don't want pointer equality, so converting them to strings makes them internable. So table x, whoa, and then we print out table x keyword and our current keyword. Okay, that's wrong. But it's at least a good sign. Yeah, because these hash functions shouldn't be the same. It's kind of strange that they would be. These two are the same, I think, unless I'm reading them wrong. 6-3, 6-5, 7-6, 7-7, 66, 7-6. Why? They should disagree on like the last character, which should be. Oh wait, can you not left shift like that? One sec. Maybe it's like one of those cases where I'm doing like a 32-bit left shift because I think that's what's going on here. Because they all cut off at the bottom 4 bytes, which in that case, the reason why things weren't converging is because the hashes that I started with in the first place could just never converge. They were just collisions from the start. That's a little odd, but note all bit operations return signed 32-bit integers. Rationale. I don't care about the rationale. I just want, like, what is the correct way to do this then? Okay, now it's even more confusing, because that totally worked once I used ULL here, but isn't... Oh, I see the issue. All this part, that's all 64-bit. But this guy, he's not 64-bit, and he's fucking production up. So, fi new uint64t, blah blah blah. Okay. Or doesn't allow how to sell some block cost. Not sure if it matters for the magic number here. It doesn't, because this number just gets this number is just any random number. It could literally just be like complete garble. It just needs to be. I just need a starting point. I could literally start at 1, but 1's just usually not gonna work. But I mean, it's gonna find it eventually. Hopefully, probably. Well, it will if I fix this bug, and I think I'll fix it now. So. That should now be something. Let's go try it. Oops. 889. And then once I've completed this thing, I just make a port of it that is, I make a PUC Lua friendly variant of this. Okay, so now everything's working. We've got all of our keywords, and they all have their respective lengths and stuff. Yeah, one sec. Alright, moment of truth. Oh, whoops. Moment of truth. There we go. So, this one's the easy case because I still have it on the setting where I put it on like 1,000 entries. So now let's go back down to a normal set of entries. Pick a prime number. 151. There we go. There we go. Now it's working. So that was the issue. The issue was just that it, oh. Oops. What did I just change? Wait. Oh, did I not save? Never mind. Okay, now it's going to take a bit. Never mind. False alarm. Although, not too false. Let's see. Oops. Eleven, 8, 7, 5, 4. Let's see. When's it gonna hit 3? 3. Okay. Okay, that's not. Now it looks like it might be working. Good news is once it does, I can just capture whatever magic number it used and then start to cache it. Although I will, yeah. And then that way, unless a set of keywords changes, the new magic number can be found first try as long as I just use the whatever magic number I find here. That way it works either if you change it or if you don't change it, because, you know, I'd rather people not have to sit through this. Let's do 157. Let's bump up the size just a little bit. Okay. 3 bits. Oh. 3. Okay, okay. Oh, 2 bits. Okay. Now we just wait. Okay. Got an idea. It does require doing that. So now I can start from the place that it failed on before, which is good. But I'd like to see if I can yeah, I wanted to print out the collisions. I wonder where it's colliding. Detection, where are you? Oh, I'm making a perfect hash table. And I needed to get a hash function in Lua. A 64-bit hash function. And so now, I'm just trying to... So for the first one, where the 2 entries were missing, we've got these 2. If only I had a compile time Game Boy emulator. Let me turn this off now. Alright, now I will just leave it. Let's be patient. Have you heard of Jai? No, I've never heard of Jai. Could you tell me about Jai? Um, yeah. I would love to hear about Jai. I would love to hear about uh compile time uh asteroids. One bit. Okay. You asking for content? I'm asking for passages out of the Bible. Okay. Happy to oblige. It's probably only a few million, like maybe 100 million, like tries away from finishing. So like, we just have to wait. Yeah. What's another Gorillion tries between friends? Yeah, while that happens, to leave was, yeah, swag. Yeah, thanks for staying. Yeah, while that happens, let's see. There was, do you stream get saved as VODs? I did archive, like I do, I'm saving this one, so I will be putting it on YouTube. Let's go pull up the YouTube channel so we can at least throw you a link for when I do that. How do I do this? Yeah, this is where I'll throw it once I, do I stream often? I don't stream often, but, I'm gonna try to stream at least once a week. I'd like to stream tomorrow, except if I do stream tomorrow, I might stream on YouTube instead. Because, I like the DVR features of YouTube and such. Oh, hell yeah. Yeah, I like the fact that, like, you know, you can rewind a bit in YouTube and such, and so I wanted to stream on YouTube today, but I couldn't because you have to like request it, and it's like a whole thing. Oh, see it. What's the impetus for streaming? I feel like it would just help me just document and like say more words and deliver value to the people and such. There's oh yeah, there was another thing I was thinking about before I got on here. There's this weird thing that happened with like value it is delivering guerrillas of value. This weird thing that happened with games where like at some point games became like you know I'm pulling on my inner John, so I'm gonna talk about games and stuff and delivering value because that's what I do. Where we stopped saying things like attention to detail and like it just started becoming like we had like technical terms like chemistry engine. Like it used to be in the case of like let's say a Zelda game that fire was all interchangeable. Like it didn't matter to a puzzle if you lit the torch with a you know another torch, or if you lit it with I don't know Din's fire, or if you lit it with I don't know a fire arrow or whatever other flavor of fire. And like we used to just call attention to detail when the fire worked consistently across different systems. But then like there became like this era where like we started assigning names to like systems that do that, like that allow us to do all the nice composition and such. And it was like, while it's cool, it's there's something funny that I feel like I've run into a few reviews of games where people talk about it as if it's like a new thing. Especially Breath of the Wild ran into this, where like people talk about it like it's a new thing that Zelda games allow you to like solve puzzles in multiple ways. When like if there's a material based puzzle in a Zelda game, it was always allowed to like be solved in multiple ways. Like as long as you had the right items, you could do a lot of bullshit. There's a case of this in like A Link to the Past that I can think of right now where I believe usually people get the fire rod before going into the Ice Palace in A Link to the Past, but like there's nothing stopping you from just like bombing every room that has fire puzzles in it. Like if they need you to light a torch, there's nothing stopping you from just lighting the entire room with what was that? What was that spell called? The fireball shit. It was the fucking. It wasn't called like a fireball. It was, what was it called? It's like the fire magic thing. One sec. Not the fire rod. It's the other one. No. I might be thinking of the fire rod. There was a specific puzzle in the Ice Palace, and I can't think of exactly which one it was. But you could solve it multiple ways by just like nuking the room. And the same thing is true with I think in Gerudo, like in Gerudo Valley or Desert or whatever the fuck in Ocarina of Time, you'd run into the same thing with like if a puzzle needed you to light something with a fire arrow, you could just use Din's fire and light the entire room because like what are they gonna do? Stop you? These are obviously not like the only cases, but at some point it became like a marketing thing, I think. And this thing is not finishing, by the way. I thought it would finish soon. I'm like looking for content to speak about. Y'all seen the new weather they be having? I'm gonna check it. I think it's stuck. But the good thing is I can check it while pausing at the exact site where it got to one thing. Alright, cool. So now, whoops. So is it desirable to allow multiple ways to do something? I think it's a good thing. It's less of me calling it out as like a bad thing to do that. It's just that like that's been a thing. Like and Zelda games are obviously not the first ones to have puzzles where you could solve them multiple ways. But like, and there are also puzzles that just have to be solved one way because they're designed. They don't have that many like sort of like input vectors. There's nothing wrong with that. It's actually like a good thing. It just became like a marketing thing, and at that point it became like sort of gamified, like whether or not you could make puzzles that are like technically solvable in funny ways, but like in practice they were solved in one way. Like we used to not talk about that, I think. I guess an example of that is like, for instance, at the start of Breath of the Wild, there were a bunch of these places where they would just put like I don't know, what were they called, bokoblins, and they would put like a ball, like just a rock that you push down a hill, and they put a bunch of these things to try to like push you to like, oh look, you can solve these things in multiple ways. You can drop down and fight them, or you could like push it down. But like, that really isn't that interesting of a choice, even if it is like a choice. Like it does die off in like flavor, as opposed to like the thing I'm actually curious about in terms of like prescriptions is like whether or not like we can design fun puzzles that can be solved in multiple ways, in ways where people want to solve them in multiple ways. Because I have run into the case of like even if you technically can do something like freely, you're still gonna do the other, like the same thing that everyone else did. I remember like when Breath of the Wild especially came out, because that's the game I'm using as my sort of like my turning point of the eras. I remember so many people I knew just all beat Zora's Domain first. And the game kind of pushes you in that direction, so it makes sense. But like it's one of those cases of like, I wonder if there are ways to make it so that games can like do the multi-way puzzle thing and not like just accidentally push you down the one route. Because Breath of the Wild was not the first Zelda game to have like out of order dungeons. We're like maybe on like Zelda, like mainline Zelda game number like 5 or 6 that had like that many out of order dungeons. Ocarina of Time had a ton of them. A Link to the Past had a ton of them. A Link Between Worlds, like the entire second half of the game, I think like, how many dungeons was that? A Link Between Worlds. The entire second half of the game is all, like, out of order. But in practice, there were a lot of things that you might solve in a specific order. Like, even though certain Ocarina of Time dungeons could be done out of order, people still did them in the same order. So, like, I wonder what is the good way to approach pushing people to, like, multiple choices without, like, accidentally biasing them. So-called free thinkers when I offer them an unordered list, but I don't tell them that it's actually unordered. Let's see. Oops. I ran it again. Don't run. Because I don't think you're going to get anywhere if you run. Favorite puzzle game? I'm not much of a puzzle game guy, actually. Enjoyed the most. I actually can't remember the last puzzle game I played. I think I played a little bit of Steven Sausage Roll, but I didn't finish it, so can't count it. Like, I barely played it, so like I really can't count it. Yeah, I wouldn't know. Just any game. Oh, okay, any game. I'm a extremely huge obsessive fan of Zelda games. So it kind of it like it's probably like depending on my mood, it's like a fight between like Ocarina of Time, Twilight Princess, and maybe Skyward Sword. It depends. Yeah. Like those three like occupy like my top one spot in like different times of the day. Maybe? What do you mean maybe? Oh, it was so it was Ocarina of Time, Twilight Princess, or Skyward Sword as like my sort of like top three. They all take the top one spot depending on the time. So it fails on one of these. I wonder if bumping up the I'm gonna bump it up slightly. That's what I'll do. Next prime number. I shouldn't close that page. Wikipedia has a very nice page that just shows you just the first 1,000 prime numbers. Alright, let's try it now. So, slightly different size, still about like maybe half or a third capacity, or like load factor. So we'll see. Ooh, okay. Two more bits. Two more bits before it's ready. But yeah, less of just like puzzles as a whole, but more of the how do you approach making it so that people don't feel pushed towards like one direction in terms of navigation, like in a way that also like doesn't just sacrifice all the other like fun bits, because like you can push for like the pure freedom thing and like get somewhere, but like that could potentially sacrifice like what you could pull off within like let's say like the story. Like, I wouldn't want to sacrifice his story to make the game more free, just because I do like stories. Yeah. Which is one of those reasons why, like, a game like Ocarina of Time or Skyward Sword sit so high on my, like, personal mind top list, tier list. What is that spam? How do you ban people? Still waiting. Cynical crab. Curious. Curious. On the list of prime numbers on Wikipedia, it says this is a dynamic list and may never be able to fully to satisfy particular standards for completeness. You can help by editing the page to add missing items with references and reliable sources. But the problem is that, like, I don't think you should. I don't think this page should keep growing with the number of primes. Okay, sorry, I haven't really played any. Was checking the order and realized there's so many Zelda games. Do people play in order or just the next best game? Yeah, people just, you can just pick up any of them. Like if I had some like recommendation of game to pick up, it would probably be Twilight Princess. Like, just play Twilight Princess. That'll give you the gist of like what Zelda games feel like, and then you just play any of the other ones you want to play. Some of them technically have like chronological orderings, like or like in universe like history like orderings and timelines and stuff, and then some of them have like real world, this game was released first kind of like chronology. You can play them in those kinds of orders, but like it really doesn't matter. You just need to know that you're like a green guy and you beat up the brown guy, and then you save the princess usually. Is it like Fable? I don't think I've ever played Fable, but let me Google Fable real quick. If it's like an action adventure game that like you know, where you're just like a person going on an adventure and you know, navigating a world and solving some puzzles while beating things up, then the answer is yes. Kidnap his sister. Oh shit. Yeah, it definitely gives. Yeah, it definitely sounds like it definitely sounds like Fable. I've never seen this game played though. Let's go see if I can find it. I might play it. That sounds fun. Okay, so now if I wait another like 20 minutes, it should be done, hopefully. Before playing, I just got a copy refunded because it would hang. Oh, that's not nice. Is it a PC game? Like, old PC? Gotcha. Let's see. Yeah, what's your favorite game? I've never heard of that game. Robin Hood, The Legend of Sherwood. Okay, let's see. You play as Robin Hood. And you kill people. This road is a criminal's lines. Maybe. I didn't actually grow up on like, especially I didn't grow up on PC games. The first PC game I ever played was like Minecraft or something. Let's see. Was this yeah. These do sound interesting though. I might pick one of these up. Let's see. If you had to recommend a game, which one would it be out of these out of these pool of your favorite games? Your graphics and replace shadow tactics. Gotcha. Yeah, I'm okay with playing a game that looks not so new, I guess. Yeah, I'm currently trying to grow my pool of games that I've played. On my current list, I think I'm missing Journey, Shadow of the Colossus, and it's like a third other thing that I've not played yet that I really wanted to play, but I've forgotten right now. because of the way that it searches for like numbers, it's gonna take a really, really long time. I kind of like games which top view. Yeah, I don't think I've ever played an RTS. Actually, no, I have played an RTS. I think there was what was that game called? I think it was an RTS. I gotta assume. How do I find it? I'm sure it was some like village building thing. It was like you're like doing some kingdom building, but I can't remember what the game was called. Let's see. I'm gonna look through Steam games. See if yeah. Was it an RTS? I don't think it was an... Actually, it might have been. Oh, yeah, it was called Majesty 2. That's what it was. I picked this up randomly at some point, like 8 years ago. When was the last time this game was updated? Majesty 2 collection. I had all the DLC. Hell yeah. I think that's what that means. Yeah, the Kingmaker expansion, Battles of Ardania, and Monster Kingdom. I wonder if there's something I can do to make this thing, like, take less time, because it really is taking a while. I've got one option, which is that, okay, so I can cache this value, and then over here, instead of doing one digit at a time, or, like, going up by one, I don't think I need to really do that. I could go up by a bigger number and be just as fine, maybe, hopefully. Let me pick a bigger prime number. The other option is instead of going up by one digit at a time, I could just feed it into a hash function and see if that gives me anything good. Let's see, does that give me answers faster? Alright, let's actually try it on one that isn't a known. Maybe. Yeah, I'm too impatient for this. Oh, are you talking? Oh, like the number of active players on Majesty 2? Yeah, I imagine it's very, very low. There was this one community that I was part of that, and the game is still around, I'm pretty sure. It's called, like, Battlegrounds 3? I think, let me check. Yeah. Battlegrounds 3 has, like, I think it's got, like, it's just, like, 4 players. It's really low. Where's that one, like, Steam charts thing? Is this the one? Yeah. So, the all-time peak was, 295. We got 22 in the last, few hours, and it just keeps doing that, by the way. It did have people at some point, but, like, it's just a tight community of, like, 20 people who all play it. And it's like this weird, how would I describe it? There's, imagine, like, the Revolutionary War. It's just that. And you just shoot people with, like, muskets, and it's, like, it takes a long time to reload because you have to, like, pack it. Let's see. What do the Majesty 2 stats look like? Give him steel. I don't know if switching to the hash function was actually a good idea. This is not... I don't know if this is converging faster or not. Oh, rip. Yeah, no, I was just saying that yeah, this is the reason why I want to switch over to YouTube because for whatever reason Twitch just doesn't do that. I was just talking about the fact that there's like 20 people who play this one game called Battlegrounds 3. Battlegrounds 3 has like only 20 people on average just ever. It's like really bad. Jesus Christ, this site. But like we've got like people did play at some point, like 200 of them. But at some point it became just like 20 people. And I used to play semi regularly because a friend of mine just got me into this thing. Ooh, this is. Let's see. Mind you, every one of these peaks is like a singular group that keeps this game alive. Because you have to run servers. It's like an old sort. It's like a. It's not even an old game, by the way. It's from 20. It's like from 2024 or something. It just looks bad. Yeah, but you've got like muskets and revolutionary fellas. It's beautiful. Or Battlegrounds 3. Yeah, I'm sure. I'm sure I still have it installed. It's one of those games that like it's only a few megabytes, so it's worth it. It's worth keeping it at all times. It's apparently 6.5 gigabytes on my disk. It's reunion servers. Oh no no no! They're not paying for servers. You host your own servers. There's just like a group of people who keep it alive. I think it's like the Atlanta server or something. They've got like a group. I think it was like 3D Clan or something. If you hop on, this is I think this is around the time when they should be playing. I left the server because they used to have like events daily and like I wouldn't participate, so I'd like it felt weird. Yeah, it's like an old source game, so you have like a community tab where people like run their own servers. So this should be telling me how many attempts it's doing per second. So that's hopefully like this does not look like a good number of attempts. Like it would be nicer if I did this in like I don't know more efficient code, but yeah, I do feel like I should do something else while this runs. Yeah. What I'll probably do is I'll just leave it overnight or something, and then I'll just like do that another time, because it's like lame content. I'm just like, kind of chatting. Let's see. I might Are you By the way, how would you say your name? Like Chagan? just realized I don't link to any of my social links. One sec. Let me do that, because I feel like it would help. Get up. Let's link a few of these. Yeah, if you're in the, what's it called? If you join the quick Discord, I can, we could hop on the one horrendous server of Battlegrounds 3 at some point. Let's see. I should put a link on this on my stream. Does that show up correctly? The good thing is it does stay around the same range in terms of like operations a second, but this is just like not fast enough or anything. Yeah. Yeah, let's see. I'll probably stop for tonight. So I'll leave this. I'll leave that just running like for a few hours and see how that goes. Yeah. In any case, disappearing now. We think I've completed something. I did end up doing something, which was the build system. I've mostly gotten the rewrite done now. It can link the quick compiler. I just need to do the CLI, and then I need to fix up the keyword hash thingy, so I can have a new and improved one. So yeah, done for now.